Hi, today is our focus will be three-phase rectification. On the previous video, we have rectified our circuit. We have used a single phase. Therefore, today let's see how we can be able to use now three-phase rectification. We can use either thyristor. I'm going to use a thyristor stroke diode. Let me start with a diode. Therefore, we need to model the circuit that represent three phase. If we go back to library, for the source you select a voltage source, you rotate, you can copy because we need three of them. Negative side you can connect, then we can put a ground here. Go back to library, utilities, we need a ground on that side. Then this side go to the main circuit. Let me put a branch here, a subsystem. Therefore, this one is our, maybe let me use U V W. These are line 1, line 2, line 3. Remember, they are usually out of phase. Therefore, this one has to be 50 to 30 multiplied by SQRT. Okay, this one is let me just copy this value to avoid repetition. The phase angle to be 0, but here to be 120. Don't forget that. Then here to be the same value of the voltage, the same value of the frequency. This one is usually 240. That's how you model a circuit to represent a three-phase circuit. UVW here. You can call this one here three phase. This is the importance of using blocks. They save a lot of time. They make your circuit become neat and organized. Let me use diode first. Instead of having very many diodes, you can use a block that is found in power electronics. Instead of using diodes as we did in my previous videos, I can now have used a universal bridge that is already designed, modeled, that can accommodate all these types of switches here. We can select, you can see here, we have Thyristors, diodes. You can use any IGBTs, but now I need to use diodes. Okay, diodes now, and I need arms, 3 arms, because I'm using a 3-phase. This one doesn't have a measurement. Measurements are none, because therefore you connect U to A, V to B, W to C. This one is a universal bridge that represent the circuit we modeled previously using diodes. If I can rename this one as can use diodes here, diode bridge. Then we need load on this side. I'm using a branch. Double click, use R only. Can use 440 divided by maybe 10 for my current. You can use any value. Then I need to connect positive to positive, negative to negative. This is my three phase. This is my diodes. Instead of modeling all those diodes, I can use this bridge that is a combination of all of them. Then my load here, R. I need to monitor the voltage here, here, and here. Therefore, I need to go back to library measurements and select my voltage measurement here. I need to measure all the voltage across U, V, and W so that I can be able to do a good comparison. I need 3 of them. Then we need a ground here. Let me just copy this, and you can just copy the paste. Okay. Then we need to monitor all these 3 of them. We can now be able to combine these 3 to make our circuit more simpler using a max. We usually have a max and dmax. If you go to Simulink signal routing here, we can use a max and dmax. Max takes many signals, then converts to one. Dmax takes one, converts to many. Let me use max for now. Let me make it bigger a little bit. I want to use 3 so that each can take its own port. You can see now how our circuit is becoming neat using subsystems, using some routing blocks makes the circuit become more neat. I need to measure voltage here still. Like that. Then I need scope. Okay, these are 3 phase, our load, our measurement. Double click the scope as usual. We need 2 graphs. I'm not going in a deeper details because now you know a lot. Therefore, I'll be just illustrating something new. Let's first run and see what happens. If you go to scope here, these are the V in. Let me first of all make it a habit of renaming your measurements. These are 3 phase voltage. This one is a controlled voltage. This is how you model controller. You're going to understand it better when you start modeling the controllers for the motors as you model electrical vehicles. Therefore, let me run. You can see now this one 3. These are out of phase. This one is 120. This one, yeah. These are 3 phase voltage. How it usually propagates. This is the controlled voltage. You can see, because you're using a diode, the reason ours is the reason why you don't have those, you can see here, is Since we're using diode, that's the reason why we have a complete continuous wave. There's no breakage of the wave. That's how you can use a diode to rectify a three-phase circuit. Let's now use Thyristors and do the comparison. Therefore, for us to use a Thyristor, I want to delete this because I want to copy this here. Then I need to copy this. I need to copy this. Okay, let me just copy one by one. In fact, make it a habit of using subsystems. They make your circuit become neat. Then we need Thyristors. You go back to library. You go to Simscape Electrical, Specialized Power Systems, Power Electronics. Then I take Thyristor, rotate it. It's okay. We don't need a measuring pot. We just need 3 of them, and we can now connect K to K, all of them. Like that. Then we need I need to connect U to A. Then I need to connect V to A, W to A. Therefore, you can do like this. You can just have some incomplete branch like that, and another one here. Oops. Then if you select this, you can still form a subsystem like that. Okay, that's how you can form a subsystem. But now I don't need a subsystem. If you don't need a subsystem, how do you collapse? Just right click on the subsystem, go to subsystem here, you expand, then select this one, delete it. That's how you form subsystems and expand them. Therefore, I need this A to U, this A to V, and this A to W, like that. Then we need to have some pulse at G, at both G's here. Therefore, let me go back to Simulink source. You select pulse generator. We need 3 of them. One for the first one, this for the second, and this one for the third, like that. Then let me first for create, okay. Then this one is our first pulse, second and third. We're going to use the same delay. I'm using a period of 0.02. We're going to use a 0.02 divided by, you know the reason why I'm doing this. We need to add an extra 120 because V is 120 away from U. The reason I'm adding 120, okay, that's the reason why I'm using 120 instead of 90. Then instead of 120, you use 240 because W is away from you by 240. Therefore, this one will be triggered. We're going to trigger the third pulse after 240 degrees so that we can be able to synchronize the third pulse with W. Double check. 90, 120. Yeah, that's fine. Then we need to measure the currents. I can measure the pulse here generated using a max. Let me see the best way to measure this. But no, I don't think so necessary. Then we need load first. In the branch here. This side you put a ground. That's the difference between a single phase and a 3-phase. You always use ground to terminate the low potential side. Then I need a voltmeter. I can copy this, Control C, we paste it here. This is our main interest, to see the controlled voltage output. Well, our max is here inside. Therefore, I can now use a scope. I can now have this one direct here. then this one on top. Let me interchange them instead. Let's have this one on top, the input. Anyway, both can still work. Okay, this is the controlled voltage. We are controlling this voltage at the load. This is the three-phase voltage. Okay, let's first for run and see the comparison here. You see, the reason why this happening is because we whenever you use two ports, always make sure you are using two screens or two axes. Always select two axes. Okay, double. You can see now we are getting the same results as similar to diodes. This is a three-phase circuit. You see now how the similar results. Now that's how we can be able to control a three-phase circuit using thyristors. In my next video, we're going to use Mosfets to control a BLDC motor. See you in that video. Share my video, subscribe, and together we are going to learn a lot. Stay tuned for more videos.